Sorry, so loud.
Okay. We're at number 15. Okay. 14. Talk about 14 is the same as 15. So there's a couple of ways to do it too. There's always a couple of ways to solve these problems. Okay. Put your drinks away.
This is showing, right?
15, Stefan. On the board. Yes. There's your brother. Give the familiarity. You know, you just like, oh my god, why can't you not? Minutes not like say those words like, you know. But if it's somebody else, you got more patience. It's like, I think in an emergency situation, I'd be better off if that's a patient versus a family member being a patient. Different. There's emotions involved. So you'll have a couple of ways doing this. Roxy did it that way. She did 14, right, Roxy?
Yes.
Yeah, converted percent to decimal, then just simply multiplied it by 30. Milligrams of drug of the drug are in 30 grams of a 15% cream. You get a picture of the cream itself, and it says on the label 15%. Jonathan has his way of doing this specific problem as well. And Megan has her way too. It'll be 15G over 100G for Megan, correct? Equals XG over 30G. We have our own ways. Okay. That's not a problem. Bottom line is, did you get the answer correct? And did you understand? And is it a repeatable quote unquote formula in your head? Can you duplicate that? Can you repeat that?
I got 4.5 per month.
That's going to be in grams,
Right,
correct?
but I have to move to milligrams.
Correct. So you will get the final answer 4.5 grams, setting up the equation. But you will notice that your options are in milligrams. So there's an extra step that you need to do, which is convert your grams to milligrams. So told you I don't like doing that, moving to the left and moving to the right, same multiplying and dividing. Okay, ration, proportion, and dimensional analysis. Okay. But he has proven me wrong. There's that one time that you're gonna get it wrong if you multiply or divide. What is that? I'm gonna put something else in there. What's a unit? Has to be lowercase, what letter M.
4,500.
4,500 grams. About 4,500. Okay. Next questions. Once you see these words, interpret or express, when you see a number and a symbol, you should spell it out. When you see words written, then you should put the number and symbol. What do I mean by that? Okay. It says in here GRVIISS, but this is conversion. Okay. So you can put just the, whatever you've converted and then the unit. Okay. On number 19 and 20, this is when you apply this. Number 19 is spelled out as 3/10 of a gram. See that? Possible answers, there's a couple. Okay, 3/10 G. But remember, this can be capital G, lowercase g, capital GM, lowercase gm. These are all acceptable. Another thing, 0.3 G or GM, but not GR. Here. So those are possibilities. And then the other one, it says number 20, 12 GTT. This means you got to spell it out 12. Faced with problems like this. Is that clear? Interpret or express. That's what we do. No, that's why it says interpret.
Okay.
12 and then drops. That's for 19 and 20. Let's do 6, 16, 17, and 18. 16, 17, and 18. Let's call our freshmen. Valentina, Karen, Valentina 16, Karen 17, Ashley 18. Okay, just tell me the answers because those are simple conversions. 16, Valentina.
0.5 grams.
0.5 G, capital G, lowercase g, lowercase gm, capital G, lowercase m, lowercase gm. All of those are possible answers. 17, Karen.
0.275.
Quarts. Take note on your final exam, there's a question on pint, on quart, and gallon. Those three come up on PTCE as well. These three conversions. Know that dram, remember I mentioned dram, we don't use that anymore. That's an apothecary system of measure. Hint, hint, wink, wink. Final exam. DRAM. It used to be spelled as DRACHM, silent CH. Gram is a measurement under the apothecary system because we're using metric when we're converting, right? Converting to metric. That was the apothecary system. We also have the abortive plot system, which are all in your textbooks. 17, I'll get back to you. 18, Ashley, answer. Correct, 66 lbs or 66 pounds. 17. Quart, I mentioned this yesterday, right? If you forgot, what's an easy way to do it? Quart is 1 quart is 1 liter, right? Because about 4 quarts is a gallon. And if you can't remember 3,785 ml per a gallon, then just do 4,000 ml for a gallon because there's 4 quarts. A quart is 1 liter. So you're just going to think whole numbers just for you to get by answering that question. Just do that. 1 quart. There's 4 quarts in a gallon. A gallon is about 4 liters. Those are not the exact numbers, but you can get by in a multiple choice question. Okay. What's on your book? What's a gallon? 3,840 ml. I have 375 ml. Okay, 340. Very close. Educated guess. Do whole numbers. Easy for us to remember the quarts and the gallons because that's what US household. We use household measurement in the US. Answer 17, Karen.
I put 0.375
No, I just said if 1 quart is 1 liter, 1.5 liter would be. If 1 quart is 1 liter, 1.5 quart is 1.5 quart is 1.5 liter is
1.5. No,
if 1 quart is 1 liter, 1.5 liter is.
1.5 quart.
There you go. Why does it sound like a question mark? Again, if 1 quart is 1 liter, 1.5 liters is.
1.5.
There you go. Okay, so if you're having a hard time, just remember whole numbers. Remember the PTCE. The PTCE is a multiple choice question. All questions, multiple choice. Okay. Moving on. 21 on the board. Nope. These are conversions. Back to the freshmen. Geo, convert 2:30 p.m. to international time.
14:30.
Good job. Who got 14:30? Hands up. 22. Jonathan. 92 Fahrenheit to Celsius would be?
33.3 Celsius.
Very good. You have to put the degree Celsius or I'll mark you wrong in a test. Okay. Good job. Who got 33.3 Celsius? Everything to decimal places for uniformity purposes, except for temperature if it's a fill in the blank question without an instruction. Okay. Number 23 is another conversion. Traditional time. 0015 is the international time given. What's the traditional time? Mark? 12:15 a.m. Correct. Okay, we do number 24 now. 24. Sarai on the board, and then we'll pause on 24 because this is the 25 problem. Might be different ways you do this, but ratio proportion would.
You erase the numbers.
What numbers do we have? Okay.
26, 30.
You know what you want covered. It doesn't matter. You know what you want me to solve on the board. Numbers, I think 26, I remember.
Yeah,
What
26,
else? 26,
29, 30.
29, 30. I think some of you have pretty much an idea what to do, but you're not sure, so you wanted it worked on the board. Black, please. I think it's on my desk. Do you know that 26 is just a matter of reading it?
Yeah.
Yeah,
Yeah?
yeah.
All the answers are on the label, except for the given part. What you're gonna do for the rest of your life is read labels, read a description. I'm gonna go around and sign your packet. Planes arrive.
Says that they inorganic phosphate. And then it said that we have available there. So I just did dimensional analysis.
Final answer, the ML, she did dimensional analysis. Anybody else who did another way? Okay, Mark, what did you do? Go up the board. Ratio and proportion is what students like to use, and I have to. I can tell who didn't do it. Okay. I can tell who tried. You're just waiting for answers. When you get here, you will be behind. I told you I posted those videos day one for a reason. You're the most difficult classes according to. Okay, another way to do it, which most people will do, probably. 5 ml equals. Okay, mark. Okay, you gotta be careful with this one. If you did ratio and proportion, this has to be what? At the middle. Equals, okay? Because when you do multiplication at the middle, that's dimensional analysis and it's worked differently. When this is equals, that's your cross multiplication. When it's multiplication here, remember your rule of fraction, you multiply all numerators, multiply all denominators before you can proceed to division. Totally different. That's how students get it wrong. They flip-flop dimensional analysis and ratio and proportion. So if you're doing ratio and proportion, this has to be equals. And correct, it has to be cross multiplication. But a dimensional analysis is not cross multiplication. You understand that? Okay. Common mistake. I've had a student who had that. That's why she gets confused. She's confusing herself. Who got that answer? What was that? Number 24? I mean, 23 ml. Number 25, Roxy, explain 25. This is what I was talking about a while ago. Remember volume, okay? Final volume minus initial volume. That tells you how much volume was displaced by that solid. Remember my example, a beaker at 100 ml level, you drop a pebble in there, the volume became 110 ml because that pebble, aka our powdered drug, will displace some volume. Okay, and the formula is simple: final volume minus initial volume. That's the amount that was displayed. So when you hear the terms on the PTCE powder displacement, powder volume, usually use a formula final volume minus initial volume. Be careful with your answer because the question is, what is the powder volume? You are to reconstitute a dry powder that is 1 gram. Picture this vial again. Okay, with this yellow powder. It's saying that this vial has 1 gram powder in it. Okay. The label states that you are to add 8.2 ml. What's that 8.2 ml called? What term?
The initial volume. So the
Diluent. That's the substance we use to dissolve the solute. Diluent. Okay, know this terminologies. But you're right, Jonathan, that you can use in the formula initial volume. The amount of water, amount of diluent that you added, that's not the final volume. This is when it gets tricky on the PTCE, because you will choose an answer that is 10 ml. And it will be one of the options. And that's not the correct answer, because that wasn't the question. There should be an extra step after that. Proxy was your friend Shalay who was confused with allegation, duration, distortion. Now she learned.
Yeah, I haven't thought.
So she was the one who got confused with dimensional analysis, duration, proportion. That's why it's good at Mark. I saw that in Mark because of students. Okay, explain. This is so nice handwriting, huh?
I labeled all the numbers that's given. The dry powder has 1 gram. That is the strength. And then the diluents or the water or sterile water that you put in to the vial would be 8.2 milliliters. And then I guess the label of the final volume would be 100 mg per ml. I converted 1 gram to milligram to get the same amount. Once I got the answer, I dimensional analysis 1000 mg times the final 1 ml over 100 mg. I got 10 ml. This is the final volume.
Final volume.
Final volume. And I subtract the initial volume from the final volume, which gives 1.8 ml. That's my powder.
And this is why, good job. And this is why I said, if this is a multiple choice question, one of the options will be 10 ml. And students usually use this. It's wrong because the question was, what is your powder volume? And let me help you picture this then. Because this is an IB problem. Okay, this is part of your IB certification. It's saying that this powder in this vial is 1 gram. Okay, and the label will say after reconstitution, the strength of this drug will be 100 milligram per ml. So this is your strength or your concentration. Follow? There's another way to do it, which may click better. Okay, in your head, ration proportion. For every 100 milligrams, for every milliliter, there's 100 milligrams of active drug. You follow? Yes? But this powder, the yellow powder, is 1 gram. To make it apples to apples, what do I do with this one? 1,000 milligrams. And this is your XML. Isn't it simpler? Right? So when you do that, since it's ration proportion, now you can proceed with cross multiplication. And this one is 1,000 divided by 100 should give you 10 ml. But this is your final volume. That's why it gets tricky on a multiple choice test. Right away, if you're in a hurry, you're going to choose a 10 ml. That wasn't the problem. The problem was what is the powder volume? Okay, and I told you powder volume can be calculated by final volume minus initial volume equals powder volume. What's the final volume? 10. What's the initial volume? 8.2. Meaning that 1 gram drug dissolved to become 1.8. Okay, picture it better. This 1 gram drug, I'm going to pull a diluent, which is 8.2 ml. I'm going to inject that in here. I'm going to swirl, and this powder will dissolve. You think it will be 8.2? No, because there's a volume that pertains to the powder. That's why the final volume came out to 10 ml, which means for you to calculate how much did that 1 gram dissolve into, final volume minus initial volume is your powder volume. Did you get that? Isn't this easier? Ratio and proportion? Who did it this way? Or who understood it this way? This, Roxy's, it clicks in her head, so I'm not going to correct that. That's how she does it, okay? But who understood it this way? Better. Because 90% of you like ratio and proportion. That's why I said I want to present it ratio and proportion way. You can still do it ratio and proportion. I want you to picture that this is how this problem goes. You only injected 8.2 ml of diluent, but then it ended up 10 ml because that powder dissolved into, that's your powder volume, powder displacement. This 1 gram dissolved to be 1.8 ml. That clear? And the reason why I try to explain it with visuals is because 80% of the population of the world are visual. You have to see to believe it. With AI though, don't believe everything you see on the internet, especially now. These AIs are becoming powerful, very powerful. I'm going to show you later. Not today, sometime. Okay. Any questions on this part? No? Okay. Remember my tips, huh? You're going to trick you. 10 ml will be one of the options in the multiple choice question. But the steps don't end there because you have to answer the problem. The problem in this particular case is, what is the powder volume? This always comes up on the PTCE, 1 or 2 questions. Clear?
Mhm.
Moving on. Number 26. Here comes 26 on the board. Yes, it's on the board. 26. Do you know that all the answers except for the give is on the label? Yes. You just have to read the label. Nowadays, I joke about this. Like, people take pictures of whatever using their phone. I take pictures so that I could zoom and read labels like this now. Yeah. There is a label there. Okay. You have to read because these labels, I told you, if there's a more accurate dosing instruction or constituting instruction, most accurate reference, it's not any book. It's the label, the package insert that came from the manufacturer. Okay. So first answer is reconstitute with 2.5 ml. It says in there on the label. For IM use, add 2.5 ml sterile water for injection. Did you see that? No math involved. For a total solution volume of 3 ml. You see how it was still 3.0? Gone are those days. Okay, this is an old label.
I didn't see the point.
Oh, you thought it's 30?
Yeah.
I read 30.
I didn't see that.
You was, oh, we don't do that anymore. This label was created prior to 2010. Remember, I told you, don't do that. So that's a 3.0. Okay, so take out that 0, it's actually 3. Okay. What's the concentration?
330 mg per ml.
Good job, 330 milligrams per ml. Do not overthink. The answers are right there in front of you. But do we have to calculate the amount of drug that we need to give to the patient?
Mhm.
Yes. And how do we do that? It can be as simple as a ratio and proportion, which is
Order versus supply.
Do your hips hurt? No. You need some exercise anyway. My eyes start to itch. I don't know how I did this job for a long time, and I struggle like this.
Good thing it's not a chalk.
I know. Did you guys?
Before it was
have
chalk.
that? Like the chalkboard? Never. Yeah, I mean me. That's my entire schooling. Chalkboard, the green board. Yeah. Okay. So, how to calculate the amount of drug that needs to be given to the patient? It can be as simple as 330 milligrams per ml, because that's your concentration, correct? Ratio proportion. Always. But what is it that you have to give to the patient?
150 mg.
150 mg over X and X rocks.
Mhm.
Since it's ratio and proportion, cross multiply. Mark, you got it now? You can't say that you think so, huh?
Which is the 150?
The order.
You see the order right there?
Oh, okay, got it.
You gotta pay attention to these details. I saw your final exam, there's something similar to this. No.
Number.
Tomorrow, that's what we're gonna do. I'm gonna go over the final exam, review you on topics that you may have forgotten, like the tenths, hundredths place. How do you do this? Okay. What's the X?
0.45 ml. Or
Did you find
0.
where we got the 150?
Yeah.
When you say order, that's the prescription. Yeah, so when you see me, when I scribble on the test paper on the board, when there's an order, I write RX right away. And then when there's a supply, I put
I
supply.
round,
That means that's what your pharmacy
Miss L, I round up to 0.5 because you can put 45 in the syringe.
has. Well, for pediatrics and neonates specific though. Yeah. That's why I said keep 2 decimal places for uniformity purposes. Okay, 0.45 ml is the correct answer. 2 decimal places just to be sure. Then I'll teach you how to do that on a syringe. Okay. Some hospitals, they do the 0.5, but it's more delicate depending on the drug for neonates. Some hospitals do in between the increments on the syringe, some don't. Okay, so you gotta be careful. And then there's an instruction, you gotta mark it. See that? So if the test given to you is like this, then you have to draw a line on that syringe where it says, isn't it 0.4 here? And then a 0.5 here. Since it's 0.45, you should draw that line. Did you see that part? I drew one on mine. In between the 0.4 and the 0.5. That clear? 27, you're now masters of this. 1 liter normal saline contains
9.
0.9.
okay, 0.9 grams over 100 ml. Isn't that 0.9%? Yes, ration proportion, if you want to do it that way, this will be X grams over 1,000 ml, because 1 liter is 1,000 ml. Then you can proceed to cross multiplication. I've been doing ration proportion almost all day. We can solve all these problems using ration proportion, so my professor wasn't wrong. Okay, and the answer is
9 grams.
I should see 9g or 9 grams or 9 gm of.
NaCl.
You
Sodium.
said NS, I'll mark you wrong.
Sodium chloride.
The solute is sodium chloride. Remember we talked about this? NS will always be equivalent to 0.9% sodium chloride. That's equivalent. Okay. So this is your solute, sodium chloride. Who got 9 grams? Who got NaCl on the second blank? Who put NS on the second? Better not. 28, is 28 on the board? Thank God it's not. It used to be in the previous classes. Because people overthink. 250 ml, and there's a similar question on your finals on this one. 250 ml, 50%. So what is that?
125.
Just divide it in half. So there's 125 ml of the drug and 125 ml of the water. Very simple, right? 29. 29's on the board. Yeah, that's a very common question. Let me tell you the answer, and I want you to figure out why. 12 ounces of 3/4 strength of the milk. Your supply is 10-ounce cans. How many do you have to use? Use blank ounces of Sistacal and blank ounces of sterile water. So many different ways to do this as well. Told you, percentage as a measure of concentration goes a long way. So it's telling you that the total of this one should be 12 ounces. So what are the possibilities, or what are the combinations possible, right? But there's another variable that you can use, which is 3/4. And you should know that this is 75%. Yeah. You have to know that 1/4 is 25%. 1/2 is 50%. 3/4 is 75%. And 1/2 is 100%. There are factors now. So you can do the Roxy way. Shortcut, you like.
That's what I
12 times 0.75. Is that what you did?
Yeah.
No.
Hey, but that's one way. 12 times 0.75 should give you
did. 9 ounces.
9 ounces. So 12 minus 9, the remainder will be your water. That's a simple way of doing it. Jonathan said, no, Jonathan, now I'd like you to do that on the board. Erase this part. Did you see how simple it is and we just overcomplicate it? Yeah. There's 2 numbers that will easily work for you.
Yeah.
We're almost done. Tomorrow we focus on the final exam. I think I can still give you a quiz tomorrow on alligation. A baby quiz, Sheena's requesting. Because Mark is requesting another quiz,
Mark.
and Gio's requesting another quiz. You already know what they did on quiz number 2. Look at Jen's face. Take a look. This is another way of doing it. It amazes me sometimes how a student did this specific problem. I'll get it. It's like, wow, that's how it worked in her head, or his head. But it can be simple, right? Okay. Well, can you explain how this worked out in your head?
Yeah, so I knew the 12 ounces was the whole thing. That's why I put the 100% there. And I decided to start solving for one of the two, which is solving for the 3/4 or the 75%. I cross multiplied like 100 over 900 is 12 times 75 is 900. Divided everything by 100 and I got 9 plus the sum. And I knew 12 was the whole thing minus 9. That's what 25% had to be 3 water.
Very good. Okay, so did you hear him? He said he knows that the total should be 12 ounces. So he placed that and marked that or tagged that as 100%. Working in ratio and proportion, he knows that this is a 75 strength. So to him, the 12% is the pure one for the whole, okay? But he only needs 3/4 of that, so he used a 75%. Good job. Any other way you did it? Roxy, did I do it your way?
Yes.
Yes.
Mm.
Converted 3/4 to 75, so
Yeah.
that's 0.75
Yes.
times 12
And then I subtract 12 ounce.
minus 9 because you got it. Who understands this now? Put this on the board. Yeah? Better? Okay, that's 29. Yes? Before what I do, I draw milk bottles. Right? To explain, because sometimes I'll have a group there's a lot of moms and it clicks better. Okay, we have to pretend we're poor. We gotta dilute the milk. No, we do this in hospitals too. Because we have concentrated milk in the hospital and we can't give those concentrated milk to the babies in the pediatric. What else? 30? Oh, here it comes. Here comes the drawings of milk I'm talking about. Who got 30? Roxy's like, I don't know if I'm gonna say me. I don't want myself to call me again. It's like she's having second thoughts. She's gonna raise her hand.
I guess.
Okay. I know the instructions kind of vague, but you just have to explain it. Okay. And if I'm to explain this, I will just say 1/4 strength is 1 part milk or enfamil in this example, and 4 parts of the solution. 1:4. 4 part solution minus 1 part milk or enfamil is 3 parts sterile water. Are you following? 3 parts sterile water is 3 times A equals 24 ounces of sterile water. Roxy on the board. Who got this 30 as well? Camille, you got this one? No? Meg? No? Okay. Let's hear it from Roxy first before I confuse you. Yeah. Oh, both moms. Very good. Sir, same exact way, sir, right? Oh, same exact way. Okay. But can you draw it in bottles? Are you gonna draw bottles? Oh, you are? Okay. She's gonna drop bottles because she saw my answer. You see, if I have a hard time understanding like the problem, I draw. And then I think practical application. So I showed them my answer key before they took their exit exam, like how I solved this problem. And they saw I have 8 cans in here. And I divided those.
That's a different question.
Oh, is it?
Yeah, that's like how many meetings in our packet. This one is asking how much.
Oh. Similar, but worked out the same way. Same stuff. Okay, cool. I know, I just figured today that those are 2 exactly different packets that I gave you. I'm glad I gave it to you again. It's just like, I want a blank one. I thought it was exactly the same. No, there's no 1 ounce
I don't
can.
know.
Wait, 8-ounce cans right there. But it's a quarter strength. You're getting it.
Just writing it.
I like how Roxy shortcuts it and Jonathan has a long way. See how it is? But he does an extra step sometimes for 2. But he gets it. That's how it clicks in his head. Okay? And that's fine. And Roxy's just like, oh, this is 0.25. So what I'm hoping is at least one way clicks. Not necessarily my way. Okay. You know that 90% of major exams is a test of comprehension. So you gotta understand the problem. There's no shame in reading the problem 10 times to get the correct answer. Finals is when? Okay, I think we could do one for tomorrow. We got 4 hours. Short one, as they requested. Short, right? Short. Short is scary though. You know that, right? Short is scary. If I give you 10 questions, that's 10 points each. I can give you short. I have a 5-question quiz.
Oh, you get 1 wrong, you fail.
Exactly. You get 1 wrong, you fail. You want that short quiz? 5 questions. You have a 3rd one. You're confusing them. Yes. Yes. But you know, it's nice when I gave them the different set. I also drew cans and bottles like this. Okay. Because it gives you a better picture. At the beginning, like when I was trying to think about this problem, I said, you know what? It's easier to understand this if I draw. And this one. Explain.
So it says here the supply is 8 ounces.
Hang on. You and Sarai work this
Yeah.
together. Okay, Sarai will explain. You did the writing. Sarai will explain. You worked on it together. Okay, good.
Okay, so there's 8 ounces, that's your supply. And then to figure out how many, and then it's telling you that in each bottle, there's gonna be 5% of milk. This is what you need to do to figure out how much of the powdered milk is gonna go in each bottle. Correct. So then we know that in total there's 8 ounces, and we also just divided 2 ounces divided by 8 That means in those, in the, 1 can of 8 ounces of powdered milk, we can get 4 bottles.
Pause right there. So it doesn't have to be powder milk. The milk that we're talking about is already in liquid form, okay? I'll continue.
So, then it says that each bottle is 8 ounces also, in here. So then we just subtracted 8 times 2, and you get your 6 ounces of water. And then it's saying, it's saying how much of still water should be mixed with each 8 ounce. It's gonna be 6 ounces of still water in each can.
You see that? Good job, you too. Okay, so first off, like I wrote, you gotta remember that a quarter strength is 25%. This is a can. This can is 8 ounces. You're gonna split this to feed more babies. Okay? And what's 25% of 8 ounces? 2 ounces. So each baby bottle, I don't want to draw, will have 2 ounces of the milk. Correct? Now you can feed 4 babies. Or you can have 4 feedings, right? But each one should still be 25% concentration. And what's the remainder? If this is 25% and each one should be 8 ounce, 8 minus 2 is 6 ounces. That means you have to add 6 ounce water for each feeding or for each baby bottle. And if you're asked how much water did you add to use up this 8 ounce can? 6 times 4. You ended up with 4 feedings. You can feed 4 babies. That's how you can think about it too. Because it's only 25% strength or a quarter strength. Is that clear? So the next question is, how many feedings did you make out of the 8 ounce cans with 25% strength? The answer is 4. Yes, Mark.
Can you go over that again? Or like how you found it? Because when I'm looking at it, I'm thinking of it like if I get 2, in order to get back to the 8, I have to, I guess, figure out how many bottles that is. So it's 4. That's 2 times 4 is 8. But how did you go over it? Because I was writing it down.
Okay. So I have an 8 ounce can. You got to picture this in terms of, Ensure, Pediasure. Okay, they're already liquid milk ready for babies to take. Okay. It's an 8 ounce can, 1 can. 25%, because the given was a quarter strength. A quarter strength means 25%. And 25% is the same as 0.25. So for me to get what's a quarter strength of 8 ounce, I can simply do what Roxy did. 8 ounce times 0.25. 0.25 is the same as 25%, the same as quarter strength. Now by solving this, I know that 2 ounces is actually the same as 0.25, same as 25% strength, same as a quarter strength. So now 2 ounces, right? Okay. There's 8 ounce cans. That means I can have 4 of the 2 ounces. Yeah?
So because it's can to bottle, so it's slightly different, right? Like, will that be how those kinds of equations are written out normally, or because in this instance you're going from can to bottles? So
This is 100%. It's pure, concentrated.
Right.
So for you to make that 100% diluted into a 25%, you need 2 ounces of that, and each one is 8 ounces. It's also given in the problem. So 8 ounces total minus 2, because you've identified the 25 strength is 2 ounces. What's the difference of that? 6, which means you should add 6 ounces of water for every feeding. That makes each feeding 25% strength. You follow? So if you're asked how much water was added, 6 times 4 is 24. If you're asked how many feedings did you make to make a 25 or a quarter strength from the 8-ounce can, the answer is 4. 4 feedings. Got it? Yeah. That's why I said when I interviewed you, you gotta know your fractions. You gotta know your decimals. Yes.
For this question.
So what's the answer? 6 ounces?
Yeah. just water.
24.
Question was for number 30, okay? It just says how much sterile water, right? How much sterile, I'm giving you possibilities in an exam, like, okay, how many feedings? And your answer is what? 4. Okay, how much water should be added? And the answer is 6 ounces per feeding. Okay. But these are possibilities of questions that may be thrown at you. So I want you to know the answers to these questions. So it's really 3 parts water, 1 part milk. If you explained it, this is my test, a quiz that I gave you. You just put 1 part milk, 3 parts water, because it just says how much sterile water. Right? You get the full point. Because it's a quarter shift. So 1 portion is the drug, 3 portions is the water. Clear?
1:3. if it's
1 is
ratio.
to, no,
No.
it's gonna be 1:4. But if it's ratio, because if we're talking strength, it's gonna be 1:4, strength. But if we're talking ratio of milk to water, 1:3. You understood how the difference goes? If it's strength, 1:4.
Mhm.
Because the denominator will always be the total. If we're talking ratio of milk or drug to water, 1:3. You get it? Correct. You understanding? Okay, so comprehension question, huh? Okay, next one, 31. Do we have 31 on the board? No, so we did 30 already. Okay, 31. 31 would be easy. Quantity to be dispensed, right?
Mhm.
Orders clapperin 1 gram, IMQ12H. The supply is a vial containing 6 ml of reconstituted clapperin with a strength of 330 milligrams per ml. So you can set it up real fast like that. 330 mg over 1 ml equals 1000 mg, because 1 gram, if you convert that apples to apples, it has to be milligrams over X ml. And the answer is
3 ml.
3 ml. Who got 3 ml? Good job. 32 is a, what type of question?
Alligation.
Alligation question, or it can be a dilution question. So either you use C1 V1 equals C2 V2, or you use the tic-tac-toe method, no problem. And I'm gonna do it on the board.
I can erase it.
You're asked to make 150 ml of a 3% sodium chloride solution using 5% sodium chloride, stock solution, and water. How much of each do you use? Well, it did specifically say use the alligation method, right? So I'm going to do it both ways. Okay. I know that this problem is a dilution problem, correct? Why did I figure out that it's a dilution problem?
There's the initial volume,
There's a higher concentration, which is
5%.
5%. And then there's a lower concentration, which is 3%. I know it's dilution, right? I can do it both ways. What's the formula for dilution again?
C1 V1 equals C2.
I gotta identify, right? Okay, it says here again, you are asked to make 150 ml of a 3% solution. So there's a 150 ml here. And that pertains to the 3%. Using 5% sodium chloride stock solution. When you see the words from, that's your C1 and your V1. When you see the word to make, that's your C2 and V2. Those are the magic words. Okay, you're using 5%. So to identify, this is my C1, correct? And then this is my C2, because it wants me to make from a 5 to a 3%. And the 150 pertains to 3%. So this is my V2. Get that? What's my X? V1. Correct. Why? It's saying how much of each do you use, but you can calculate this so you can calculate the rest, correct? Let's see if C1 V1 equals C2 V2 will work out. Who did C1 V1 equals C2 V2? No one? Oh, you like tic-tac-toe, and that's fine. Okay. How did I do the C1 V1 equals C2 V2? I used 5% as my C1. What's my V1? I said it's X, right? What's my C2?
3%.
It's 3%, because it didn't tell me to use alligation. Huh? What's my V2?
150.
Okay. Because this has the X, I have to divide both sides by. You see that? Last year. So this will be X equals 3 times 150 divided by 5 should be, what is it?
90.
9 what?
90.
90
ml.
ml. You have to label this correctly,
Mhm.
okay? You put 90 ml here, but this is 90 ml, that I remember, of 5%, right? So the question was how much of each? You just solved this one, right?
Mhm.
90 ml of the 5%. You got a total volume, right? So what do I do? 150 ml minus 90 ml equals,
60.
which means I need, do you see that? I
Okay.
need 90 ml of the 5%, and I need 60 ml of the 3%.
I put
And that adds to,
the 60
sorry,
ml
water.
of water.
I'm
Yeah.
sorry, that's 60 ml of water, correct? To get 150 ml, 3%,
3%.
correct? You see that? Higher concentration plus water, you get the, that's one way. Because it's dilution. It didn't specifically say use alligation. Did it work? Did the formula work? It worked. You just have to label it properly. What you will get here is the volume of whatever's looking for first. It doesn't end there because the question was how much of each do you need? And you got to remember that this is the total volume. So if that's the total, how much water was added? 60. It worked. Here's another way to do it. You ready? We did tic-tac-toe here. That's okay. Let's do tic-tac-toe. Higher concentration.
5%.
What's the lower concentration?
0.
0, because we're using water to dilute it. That's why it's a dilution problem. That's why the C1V1 equals C2V2 worked. What do I put in the middle? 3%. What's the next step? Crisscross. Absolute value, 2 parts. Crisscross, 3 parts. This is when it's a Miss L way. You make it 5 parts. I bring this down, right? So that I know that this particular row pertains to the 3%. So I'm not confused. And this particular row pertains to the 5%. And this particular row pertains to the 0%. There's another variable in there. What did it say? The total is 150 ml, so I should plug that in here. Because it's saying on the problem that the final should be 3% total 150 ml. Now, another Miss L way, let's do ratio proportion. So if 5 parts equals 150 ml, which one do you want to solve first? It doesn't matter. The 3 parts, let's solve the 3 parts. 3 parts is to X ml. And the answer here is
90.
90 ml of your 5%. That's why I started doing this. Putting them in rectangles or in rows. Won't find it in any book. 90 ml of the 5%. Did you see that? So here you can proceed by 150 minus 90, then you still get
60.
60. But you can also do the parts if you want to. Yeah. If 5 parts is 150 ml, then you calculate this. 2 parts is X ml. It should come up the same. What is the answer?
60 ml.
60 ml. Want to check? 90 plus 60 equals 150. If it didn't specifically tell you to use the alligation method when it's a dilution problem, C1 V1 equals C2 V2 works. I just use this on test because it's faster. It's just faster. But you have to have good knowledge and foundation of alligation. So what do I do when I'm taking tests? If it's a dilution problem where there's 2 strengths and you need water to dilute it, dilution, there are only 2 strengths. I use this formula. If there are 3 strengths and water is not one of them, I use it. But this just shows and proves to you that you can use alligation, the tic-tac-toe method, even if it's a dilution problem. See that? But you have to use 0% for water. And a pure substance, 100%. Who understood this one? Now you do, did you understand it prior? No. Is it easier? Isn't it easier? That's why. Number are we now?
Before. Wait.
33. So I guess you could do this now. Who didn't understand 32 before I explained it?
So actually, all the milliliters, all 3 right? Okay.
Yeah, because it's given in milliliters. Yes. Who didn't understand 32 before today? Who did not understand 32 before today? Okay. Do you understand it now? Yes? Yes? Okay, Mateo on the board, 33. Let's see. This time, what should I use?
Alligation.
Can you use C1 V1 equals C2 V2? No! There's 3 strands, so what should you use? Alligation, the tic-tac-toe. But no one is stopping you from using tic-tac-toe for alligation if water is involved, meaning dilution. Just use 0% for water. Some students like using alligation, even if it's a dilution problem. They just use 0% for water. Okay. We're at number, almost there. We're at number 33 now. Think, if you just follow the way I do it. Number 34, answer. Is this another allegation question? Not really. It's a ratio and proportion question, a percentage question. You see how it hides from a word problem? But you can solve this using a simple ratio and proportion. How do you do that? You convert your 5% into 5 over 100, because that's 5 grams over 100 ml. See that? A lot of questions like this on the PTCE. What's the proportion? X grams over 280, correct. So the answer to number 34 is
14 grams.
14 grams. Who got 14 grams? Hands up! 36 problem, which you want me to solve, is similar to what we just did on the milk. But this time the question was, what is the ratio for what? Medication to water, which we were discussing a while ago.
Don't know where to go after this.
Chris, go. Yes. Absolute value. Subtract. Right? And then 69. Okay, start drawing your rectangle. Neil, can I help? Neil will help. She did the crisscross part. Next part. I know she was absent yesterday, so she needs to catch up. Now, you freshmen, you guys understand why I said watch the videos. I asked you to watch the videos, you will watch the videos. Because we don't have a lot of time. There you go. Imagine if that's chalk. I remember I had a professor whose nail always breaks from the chalkboard. Like, pause here and then read the problem again so that I can plug the volume at the correct row or box. I like this, whatever's happening in the P7 is another dilution. Use tic-tac-toe. You can use C1 V1 equals C2 V2 for 37. I love this. Really. Yeah. Who wants to quit tomorrow? Nobody. Margaret. You know, the good thing is, on this particular class, it's heavily weighted at homework. No. I'm ready anytime. I have a 5-question quiz too. Scary, right?
I'm just like, this one you get.
That one is really high, right? If I give you a 5-question quiz tomorrow, your chances of passing that is down, right? Because each, let's check your percentage. 5-question test, each one will have how much percent? 1%. Did you understand the payout? I really wanted her to jump in there so that she can show you that. Now continue, Camille, explain how you explained it to Mathea.
So, we did the tic-tac-toe.
Read a problem.
Says how much 10% dextrose solution and how much 60% dextrose solution should be mixed with 2 liters of 40% dextrose. So the first thing we're gonna do is convert the 2 liters to milliliters, so that should be 2,000 milliliters. And then since we know that 60 minus 40 is 20 parts, and then 40 minus 10 is 30 parts, we know the 40% equals 50 parts. If we add this together, it brings 40% down. And then that is also equal to 200. So for the 10%, we know it's 20 parts, 40%, we know it's 50 parts. And also it's 200 over 200 milliliters. So we did the ratio proportion, and we cross multiplied to get 800 milliliters for the 10%. And then what I did was just subtract 2,000 milliliters from 800 to get 1,200 milliliters for this.
You know, I didn't learn alligation this way back in pharmacy school. It was different, it was fractions, but then through the years I was teaching it, I realized students really like ratio proportion. So I figured out a way to do it ratio proportion, and then I added the rectangle. Why? You're not looking all over the place to draw the boxes or the rectangle. You know that this pertains to 60, this pertains to 10, and this pertains to 40%. I just developed the rectangles probably the last 2 years to even help the students. Because it frustrates you, why are they not getting this? What we did back in pharmacy school, if you want to know, it's 20 over 50 parts. And then 30 over 50 parts. So for people who don't have strong fraction calculating skills, if I may say it as much, you're lost. But I noticed through the years, ratio and proportion always clicks with students. It's gonna be a fraction way. Isn't it easier now? Draw those rectangles because it tells you exactly, is this for the 60? Is this for the 10? And then I brought down the one in the middle, so you're not looking everywhere, right? Now it's another row. Tells you that that's what you're looking for. That clear? There's always a way to make things easier. Who got this one before today? Hands up. I'm expecting yes for juniors and seniors.
I didn't.
Yeah.
I feel like I should did it.
Who understood it now?
I did barely got it, because I was dividing, I was reading the description by percentage.
So what?
Yeah.
And I think Jonathan knows how to like stay away for a little bit. That'll work. He knows how to zone out. Numbers 34, you got that 114 grams? Running out of time. Number 35, this is the ratio, however, any ratio can be converted to percentage. Can be, you can use ratio proportion. How do we do that? 1 gram is to 2,000 ml. That's 1 is to 2,000. That's what that ratio should be telling you. 1 G over 2,000 ml. So equals xg over 1,500 ml. Then do your ratio proportion, cross multiply, and your x is
0.75.
0.75 G. Good job. Number 36, this is the last. You don't even have to calculate any of this. Really? Really? You don't.
I got 1 to 3. I don't know if I'm right.
Correct. It's 1 is to 3. One, because the question was, what is the ratio of what?
I calculated it, that's why I got one.
Oh, show them if you calculated it. So like, why am I even putting my mouth? Okay, she got it correct. 1:3. 1 part is to 3 parts. 1 part of what? 1 part of what?
Sodium chloride.
1 part of the sodium chloride and 3 parts of the
Water.
They're
Water.
water.
You get it real fast, okay. So Roxy like to do ration, allegation, tic-tac-toe for this one. You know what I did? Maybe because of practice. I just know.
So I
that
think
there-
you subtract 0.9 minus 0.225.
Do what you're doing. I just know that 0.225% sodium chloride is a quarter strength normal saline. Try to do it. 0.9 divided by 4. I just showed it to you. Ratio, did you do those 3-page practice
Yeah.
on IV? A quarter strength normal saline is 0.225. Which means if it's a quarter strength, the ratio is 1:3. As I said, I don't need the math here, but I was wrong, because I was a practitioner, I know that I already pictured that this is a quarter strength normal saline. So without doing the math, I know that it's 1 part salt, 3 parts water.
Quarter was one.
But this is good too.
Yeah.
This is allegation. Another way you did it, anybody else? Explain.
Oh.
So, the total volume should be the 0.225, and the technician have to mix 0.9 of sodium chloride and 0 water.
Normal saline.
So I subtracted that, and I got 0.225 for NaCl, and then for the water, 0.675 parts. And in order for me to get the ratio, I have to like have a fraction.
Yeah, it has to be a fraction,
Yeah.
correct? This is a ratio.
I put 0.225 in my numerator, and then 0.675 in my denominator, and I simplify it. It gives me 1/3.
1/3. Very good. That's a good way to do it. You see, I'll explain to you again why I said, oh, no math involved. Why is there no math involved? That's just me because I've been a practitioner 25 years, right? When you say normal saline, it's 0.9% sodium chloride, correct? I know at the back of my head that a quarter normal saline, which 3 pages of practice for you guys, remember that? Okay, is 0.225% sodium chloride. Try it. 0.9 divided by 4. Correct? And if I know that this is a quarter strength, I already know that it's 1 part is to 3 parts. 1 part of the drug is to 3 parts water. That's why I said you don't even need to do the math. But this is a good way to show you. But this you gotta be strong in fraction. Even if you divide it, it's gonna be the answer 0.33.
0.33.
0.333, and that should tell you that's a third. And a third converted to ratio is 1:3. Did you see that? Good. Easy. Who got 1 to 3 hands up? Next one. What volume of a 23% sodium chloride solution is necessary to make a liter of 0.9% normal saline? You can use C1V1 equals C2V2 because it's a dilution problem. You can also use tic-tac-toe by using 0% on water. And what's the answer?
39.1.
No. 39.1 ml. Okay. Why? Double check, Jonathan. How did that happen? Your C1 can be 23%. If I'm using C1V1 equals C2V2. Your C1 is 23%. Your V1 is X. Okay. What's your C2? 0.9%. And what's your V2?
1,000.
1,000 ml. This is X ml. And what do you do next? Divide both sides by 23. Then you should get 39.1 ml. Can I do tic-tac-toe? Yeah. Just use 0% on the water part. Did you see that? The only question was, what's the volume of NaCl? Okay. What volume of 23%? So it's on that side, 23% side. You get that? Number 38 is very similar. You can use C1V1 equals C2V2. The answer to number 38 is
2 ml.
2 ml, correct. 39 is a percentage question. We're going to go over this tomorrow, okay? But I'm giving you the answers. 39 is a percentage question, and the answer is
150 ml.
150 ml. And number 40 can be solved using C1V1 equals C2V2, and the answer is
500 ml.
500 ml. Okay, we're going to do the remainder again tomorrow from numbers 37 to 40 before the quiz. Okay, and then finals on Monday. Any questions? No questions? Who's staying for tutoring? Okay, we're gonna move class.